video is part 2 of fitting the Trispark electronic ignition system to my Mk2A Norton Commando Mk2A. There will be a part 3 because that part will be to do with timing the engine, or dynamically timing the engine using the stroboscope, because of course you set the static timing according to the Trispark little booklet. The booklet also advises certain preliminary setting up procedures. The main ones are to do with preparing the bike ready to take a Trispark ignition system, and they talk about removing the points plate, changing the wiring, removing the ballast resistor if you've got an electric start bike, and such things like that. Specifically for the Trispark ignition, having taken all of the old ignition parts out, you then need to actually work through their list. One of the first things they suggest is to ensure that the Allen screw that you use to mount the rotor, the Allen screw doesn't bottom out. Now they supply 2 Allen screws. They provide a 26 thread per inch BSF Allen screw and a 24 threads per inch UNF Allen screw. I have prepared all the electrics ready for fitting the Trispark system. So the ignition switch, when you turn it on, powers the motorcycle, and it's a 4-position switch, brand new, and arrived faulty, would you believe? So in the parking position, where just the side light should be on and you can take the key out, that doesn't work. Well, it's very intermittent. However, the next position, when you also take the key out, is off. That's fine. When you switch to ignition only, that's position 3, that will power up the ignition on the bike and such things as the horn supply and the brake light supply, and potentially the hazard flashers if you've got that fitted. And then obviously the 4th position then turns on all of the lights as well. So in position 3, where you've got the ignition on only, that is actually putting power on to, according to the Lucas wiring colour scheme, the white wire. So the white wire comes up the back of the bike and up into the headlight and such like, and you can see some there, and there's a spur off at this point, which then comes down and goes onto the coil, and then there's also a power that comes out of the coil and goes down to the Trispark box, and then there is a separate wire which is the white wire, but is now coloured red, which goes down into the Trispark area. One of the checks that I like to do over and above the requirements listed by Trispark book is to measure the wiring. This wire is on the output side of the ignition coil, and this wire is actually the power from the ignition switch. The with all the power off, to measure the resistance between those points is to measure the primary resistance of the coil, and that should be 3 ohms. And then with the power on, but without the Trispark box fitted, with the ignition switch on, you should get 12 volts on both of these terminals. The caution should be exercised, because of course if you actually touch this, the black and the white wire to ground, you'll flow current in the ignition coil, which is not a bad thing. But when you actually remove that ground, the ignition coil will fire, and that energy has to go somewhere. That energy stored in the coil will then either come out through the ground, or it will come out through the spark plugs. And as long as the spark plugs are fitted, that's not an issue, because the energy can then dissipate. If, however, there's no spark plugs, the energy has to go somewhere, and it's going to actually try to find the lowest resistance way out, and that's often through the windings of the coil, or the insulation of the coil, to a ground point or to some return point. So there is some caution to be taken there, and while wiring everything up until you're happy that all the insulation is correct, I would suggest removing the power from the battery or whatever. Don't just rely on the ignition switch. They have proven to be a little bit unreliable, shall we say, even though it's a genuine Lucas, well, supposedly genuine Lucas one in a Lucas box and all the rest of it. To arrive faulty is one of the preliminary checks Trispark asks for, is to identify which Allen screw fits into the camshaft, and to make sure that it's not going to bottom out before the taper on the rotor is engaged, so that the rotor could actually spin willy-nilly as it will. So you need to actually screw the Allen screw in. This is the 24 teeth per inch UNF version, and as you can see on this camshaft, it screws all the way in. The camshaft in this is a John Smith, a production camshaft, and obviously it's a little bit potentially different from the camshaft that you might have in your bike. The supplied Allen screw is 1.5 inches long, and I calculated that the distance from where it sits inside the rotor to where the rotor shoulder almost butts up to the back of the case is 0.448 of an inch. So that suggests that the engagement into the camshaft is about 1 inch, and of course some of that will be shrouded behind the taper. So the Allen screw to fit that in is a 3/16. Now, the next thing they ask you to do is to fit the stator into its mounting place, and I found to keep it in there I need a pillar bolt. Makes it easier, and there are a couple of things that you need to observe. Get down there. The stator for the Norton Commando is a counterclockwise one, and there are a couple of mods that you need to do because this is a negative earth motorcycle, and I will detail those for you. But one of the things that they ask you to do is difficult to see, is to actually put a line on the casing where the B mark, because this is a counterclockwise unit, so it's the B mark, where the B mark is. Which I have done. I have made the changes and completed the wiring on the stator, and I also did a calculation on how much variability you can get on with the slots that are there, and there's approximately 30 degrees of setting. So if you get it set in the middle of the slots, you got plus or minus 15 degrees of play, assuming of course that you've got the engine set right, and I checked that it's at 29 degrees before top dead center. One of the checks that the Trispark ask for is to ensure that the face of the rotor is behind the ledge that the stator sits on, and they specify 2 millimeters, and they actually provide a tool, a piece of perspex, to actually lay across that area and allow measurement of the gap. Now I tried with feeler gauges set for 2 millimeters or 80 thou, and it doesn't fit. You can't get it round the corner. Now, and I don't have any feeler gauges that have little bent ends. So what I found are 2 washers which combined together with the glue in between give me 2.1 millimeters, and I can actually slide that in there, and I actually have slightly over 2 millimeters of space between the face of the rotor and the ledge where the Trispark unit fits. So the next stage is to bolt the rotor in using the pillar bolts. These pillar bolts you have to provide yourself. They're not part of the kit. And these ones are specific for the Norton Commando. The pillar bolts don't want to be completely tight, but you do need them tight enough to make the ground connection. And what they suggest is that you should be able to rotate this unit around on the slot, so that it moves all the way. And the initial setting is for the Trispark to be rotated fully counterclockwise, ready to set the static timing. Having checked that the engine is still set to 29 degrees before top dead center, when you actually set the position of the stator, you've actually timed the engine such that it's as close as possible to a starting position, so you can run the engine and get the strobe on it. So I switch the ignition on. Yep, we got power. Now what they suggest is that you rotate this unit until the LED lights, and as you can see, it hasn't rotated very far before the light comes on. The slot is roughly in the middle. Having found the position, I'm now going to tighten up the pulley bolts a little bit at a time, and then check that the LED still comes on, which it does. The final stage is to actually tidy up the wiring such that it will sit within the cover, and obviously to fit the cover. Note that there is a small drain hole that should point downwards, and then the screws will actually fit into the cover, and of course this cover may need to come off again while strobing the engine to adjust the stator if required. But fitting the cover at this time protects the work that was already done. Voilà.